Hey guys, hope you're doing well. I am back in the lab today, back with another lab vlog, and today we're talking about some of the reagents, chemicals, buffers, bits and bobs that I use in the lab that you may use, and sharing some advice as to why I use them, how I use them, and how you can make use of them. So if you're new, I did a lab vlog tour of the lab itself. Now I'm going to take the tour one step further and show you the stuff that I actually use. Let's go to the first drawer, which is over here. Let's get cracking. So believe it or not, I think the best way is to show you on here what each item is and share some bit of information that might be a benefit for you. So, first one is, this is a box here. This is something known as sodium orthovanadate, and if you do anything to do with proteins or extracting protein from cells, you might use that, and it's something known as a phosphatase or phosphorylase inhibitor. I can remember the right term, and it's used to try and help stop phosphorylation of proteins at that point in time. So when you try to observe its activity through Western blot or IP or anything like that, you can try and observe the activity in real time. This is another one, fluticasone. This is actually a steroid. So obviously, for those who may not know, I work in the severe asthma side of research. I'm looking at how steroids actually affect patient response, or how people become resistant to what we call corticosteroid resistance with patients. Something known as LPS, you can see it here. LPS is lipopolysaccharide, and it's a, you can say, a trigger for inflammation, especially from the kind of asthmatic point of view. So we know that certain growth factors, certain stimulants within the body can trigger, or certain allergies can trigger, and LPS is known to be quite a known trigger to induce asthmatic kind of responses or allergic responses, and we use it as a kind of like a positive control, for example. So some more is, oh, if I can get it out, antibiotic and antibiotic. If anybody does any cell culture, you will know exactly what this is used for. It's how to minimize infections when you're growing cells, and some people use pen strips, so penicillin, streptomycin. I used to use that in my PhD. This is, I think, more well-rounded, so it helps to try and prevent infections that you might get whilst growing your different cells. Moving up further. We have Reaper buffer. So for those who, again, are extracting proteins, you might be using Reaper buffer, and Reaper buffer is quite a strong way to lyse cells to extract out the protein. There are different forms, but Reaper is quite a well-versed one, so you can add certain cocktails. That means you can add these phosphorylase inhibitors. You can add other forms of inhibitors to preserve the protein, and you can add other detergents to try and break down the cells. So there's various things, SDS to try and break down those disulfide bridges. You can also do that. The breaking of protease inhibitors, so to stop enzymes that degrade proteins. Here's my protease inhibitor cocktail. We have that, and then we've got my trypsin aliquots. So for those who, again, do cell culture, trypsin is used to cleave off the cell from the surface. And then tons of FCS, so fetal calf serum. So I have two versions. I have iron supplemented and non-iron supplemented. So for HMC, so for human mast cells, the cell line, we use iron supplemented, and for various other cell cultures, for you can say airways with muscle cells, other forms of cells, we use just a generic fetal calf serum. But I leave one of the special ones to last, which is this one over here. This is what we know as anti-Fc epsilon R1 antibody. Now, before my shins break because I'm kneeling down, bear with me one second. So, anti-Fc epsilon R1 antibody is used to directly trigger mast cell activation. Now you might see a diagram here of a mast cell and these certain Fc receptors. Now a very famous way of doing it is using IgE, which we know is related to kind of allergies, and it's known to fairly well actually activate mast cells. But anti-Fc epsilon R1, which is a long word, It's a more direct activator because it has a very high affinity to these FC receptors. So with my work, I'm trying to activate muscles similar to what happens when somebody has allergy, and then looking at how these activated muscles affect certain cells or certain environments. And we use this, an anti-FC epsilon R1, to try and do that. So that's my actual lab bench over here, or drawer over here. Let's go to my other drawer just to show you some of the samples that I actually have. So guys, we're back in the other lab. It's going to show you now the other drawer that I have and some of the things that I have in this drawer. So we have TNF ELISA kits. So I do a lot of ELISA. For those who may not know, you might see a lot in the stories for the past 6-7 months. I've been doing a lot of ELISAs. So that's the TNF cytokine. Then I've got the GM-CSF. So again, I forgot what it stands for actually. I'll put it here. But again, very potent cytokine that it gets released in the early phases of mast cell degranulation. So that's a very important cytokine that I look at. Some more Reaper solutions. Again, I mentioned it early on in the video. DNase aliquots. For those who do RNA extractions, you know what I mean. We use DNase a lot to help get rid of the DNA so we can extract nice pure RNA. Then I've got some more LPS and then loads of these kind of antibodies that you see. So these are for different phosphorylation sites of the glucocorticoid receptor, so essentially the steroid receptor. So I've got different phosphorylation residues and different antibodies related to that. So we've got some more. So we've got the receptor, we've got the phosphorylated receptor at a certain site. So that's what I have. Then I have these. So these are, it's a long name, so I'll put it here: 4-nitrophenol N-acetyl beta-D-glucosamide, and then 4-nitrophenol N-acetyl beta-D-glucosamide, which is essentially a substrate that is used to get catalyzed by a certain enzyme that is found in mast cells. So to better explain this, let me just put this all the way first. When we want to measure the activity of mast cell activation, what we tend to do is there are certain enzymes that get released, and one is known as beta hexamidase. I'll put it here. Now, this will catalyze a certain substrate, i.e. those two tubes you just saw, and it will cause a color change depending on a buffer solution that you have in the well. So what you would normally do is you have a salting solution, add in your mast cell supernatant, so the mast cells that you have activated using that FC epsilon R1 or IgE, whatever you might use, and even other stimulating factors. And then if you have seen activation, it means that enzyme has been released from the mast cell, and then it will catalyze any of that substrate that is in the solution into another color. So similar to many conversion colorimetric changes that you see with certain assays. And the more color change you see, the more of that enzyme that was there, and that might be linked to the more increased or more enhanced activation that you might have triggered with muscles. So that's why that is used there. Now my legs are in. So those are the two kind of fridge boxes that I have and drawers that I have. But then let's just go to the final area, which is my kind of lab bench resources. I'll show you some of the stuff that I use over there. So guys, this is the kind of lab bench area that I have, because for those who may not know, I don't have my own lab bench because I only work here part-time. So this is where I kind of store the lab resources, kind of the bench resources. And a lot of it is essentially the kind of buffers and reagents. So that assay I mentioned to you about in terms of analyzing mast cell activation via an enzyme, we use stuff like sodium bicarbonate, sodium carbonate, trisodium citrate, citric monohydrate, stuff like this, to make up those buffers that we need for that assay. Now, along with that, we have the usual ELISA buffer and wash buffers and stuff like that, reagent diluents. Got, running buffer and transfer buffer for Western blot that I use. Everybody knows about Trisma. Then we've got, salt for your chips. Don't use this, alright? Don't quote me. It's the sodium chloride. But we know that sodium chloride is also salt, but don't use that for your chips. Just don't. And then we've got all sorts of tip boxes. We've got plates for Don't know if you can see, let's bring it in closer. We've got those which are the PCR plates, for those who know about PCR and do PCR. They've got stuff like this reservoir. I'll come back to this because it's actually quite handy. Various, you know, PBS, stuff like that. Pure water that I've got over here. Yeah, water. We've got water over here. And then got this. So I don't know if you know about this. This is for a Rannin pipette. Now, if you don't know what Rannin pipette is, or haven't come across it, do subscribe to the channel because I'm going to be doing a future video on how we use this special type of pipette. Because what it does, imagine you have a tray of samples in this tray over here, and you put a multi-channel to grab stuff from all of the samples, and then you want to put it into a 96-watt plate, which is like this. Obviously, it won't fit because the spaces are different. But what this pipette does is allows you to swivel and narrow the distance between the tips, so you can squeeze it to fit in here, and then you can expand it to fit in here. So I'll show you how I use that in the future videos. So do subscribe to the channel if you want to see that. Click that notification bell so you are notified when I upload. And the reason why I mentioned back to this is these are really, really handy if you're doing any multi-channel work, which I do quite a lot of in this job. And these are really helpful to, you know, you've got buffers or solutions, dip in your multi-channel, and then you can make your life a lot easier. However, if you cannot afford that, because I couldn't during my PhD, what we used to do is, if you're working in the hood and we're using sterile tips, once we finish and that, you know, tip box is empty, what we used to do is, because it's all sterile, it's still inside the hood, it doesn't come out the hood, we would open out the lid, and then we would take the lid and then pour our solutions onto here, and then just leave it at an angle like that, so we can dip in our multi-channel and then pour that solution into a different 96-watt plate. So this was a free way to get this, essentially. So I'm hoping to share little tips and tricks that I've learned over the years in research on this channel in these types of vlogs. So if you do want to say, do let me know if you want to hear more of those kinds of tips. But that's your tip for the week in terms of lab tips. But yeah, the rest of it is just various, you know, bits and bobs of boxes, types of plates, fluorescent plates. We've got various other like bits, general reagents that you probably have in your lab anyway. But you know, what I've shared is what people know already. You know, a lot of the stuff in the lab are antibodies that people know. Those tubes are famous assays that anybody knows. So it's not like I'm sharing anything confidential. You know, if I was worried, I'm not sharing what samples I have, or what, you know, incubation times, or, you know, time points I've done, or the methods of certain experiments. You know, so there is, for those who want to share stuff in your lab, you can do it. You know, all of this is all commercially available. You can buy this. I'm not sharing anything that is scary or patented, if anybody was concerned about sharing stuff from their lab. So I hope you enjoyed today's vlog type. You know, I showed you the tour last week, and this is obviously now showing some of the stuff that I actually use. If you do enjoy these types of videos, do consider subscribing, as you can see over here. Click that like button so it helps to generate the video to other people who may also enjoy it, and helps the algorithm and me to try and progress so I can share more videos to you all. Do consider following me on Instagram, because I'll be sharing more tips and advice over there, Aamir.phd. And if you want to email me something a bit more concrete or detailed, Aamir@researchtribe.org. But I shall stop talking, tidy up, because I need to tidy up. If you're working in the lab, you need to tidy up too. Make sure you don't leave a messy lab for other people. And I shall hopefully see you in the next one. Problem is now, is that I need to get up. And I'm quite old. Well, my legs feel old. So you go watch another video over here. You can see where I'll share some tips and advice regarding lab work. Or if you want to actually listen to a walkthrough of my whole PhD thesis, you can watch it over here as well. So whilst you do that, I'm gonna get up. But see you in the next video. Oh.